This video is going to explain the process of how to draw Bohr diagrams. So again, a Bohr diagram is a model that we use to help us see how the electrons are configured or arranged around the outside of the nucleus for an atom. And once we have the diagram, we are then able to see exactly, or able to use that model to determine how reactive our element is going to be. So let's say, for example, I have chlorine, which is number 17 on the periodic table, meaning it has 17 protons. Now again, atoms are neutral, so however many protons, and remember protons have a positive charge, that's how many electrons we have. So if there's 17 protons, that means I also have 17 electrons. Okay? So once I know how many electrons that I have, the very first thing you want to do is you want to draw the nucleus of the atom, and inside of that write how many protons that atom has. So again, since I have 17 protons, I know that I have 17 electrons, so I have my number of electrons determined, and so now I can start placing my electrons into their different energy shells. So the very first energy shell is the closest to the nucleus, and so it's also the smallest. And so since it is the first, it can only hold 2 electrons because it's so small. So I'm going to go ahead and draw my 2 electrons into that first energy shell. But now remember, I have 17 electrons total. I just subtracted 2 for the first energy level, which means I have 15 electrons remaining. But again, my first energy shell is full. So I need to draw another energy shell. Now, this is not 100% true, but for the purpose of this class, we're going to make the assumption that every single energy shell after the first can hold exactly 8 electrons. Now, it doesn't have to hold 8, but that's how many it can hold. So I have 15 remaining. My second energy shell should be able to hold another 8 of those electrons. So I'll fit another 8 electrons into my second shell, meaning I will have 7 electrons remaining. Okay, and now I'm going to go ahead and draw those into my diagram. Now here's what's really important. When we draw the electrons into our shell, we want to pretend it's like a clock, like 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, okay? And we want to draw an electron at each one of those times before we start pairing. I'm going to put 8 in here total, but I want to draw 1 electron at 12, 1 at 3, 1 at 6, and 1 at 9. So that's 4 electrons total, but I know I can hold 8. I need to add the next 4, and now I'm going to start to pair my electrons off. Okay, at first we want our electrons to spread out because negative things repel each other, but then they do eventually want to have a partner. Okay, so that's my second energy shell. It is completely full, but I still have 7 remaining electrons. So I'm going to draw 1 more shell, my third level. Okay, and again, we're going to make the assumption that every single level after our first can hold 8 electrons. So now that I have my third shell, I can start putting in my next electrons. And I'm going to do the same thing I did with the second. I'm going to go all the way around at 12, 3, 6, and 9 before I start to pair. So I got 1, 2, 3, 4, 5, 6, 7. Now if I count up my electrons, I have 2 plus 8 is 10, plus 7 is 17. So I have all of my electrons accounted for, 0 remaining, and that is my completed Bohr diagram.